Hello and good morning. So today is the third day, and out of the 10 videos that I suggested that I will be doing, today is the third video, and today we will discuss about chapter 3, and as it was planned in the tutorial, that I will go figure by figure, and then I will explain so that if you have a copy of the book Nanobrain, the making of an artificial brain, using a time crystal. If you have that kind of, if you have that book and you really want to understand it without reading, just by listening to me and going through the figures and then avoid the complexity of the text, then this is the uh, right video. You are at the right place. And then today we will discuss about chapter 3, all the figures, and you will be able to learn after this presentation what is actually the fundamentals of this uh, particular um, particular chapter. So chapter 3 is all about creating the core architecture, to core mathematical architecture of the artificial brain that we want to build. So in the chapter 2, what we have learned? We have learned that whatever be the information that is happening in the universe, we can convert it in terms of 3D geometric shapes. So we will take 15 geometric shapes and we will arrange them in a very particular pattern. So normally it could be 3D, but it will have certain geometric features that would incorporate 11 dimensional dynamical features. Why 11 dimension or 12 dimension? Four dimensions are actually spatial and temporal. Four dimensions related to time crystal, exclusively for time crystal, four additional dimensions, 5, 6, 7, 8. And then 9, 10, 11, 12, the four dimensions come from mathematical complexity of the primes, and those dynamic features is actually included. So basically in chapter 2 we learned that um, that universe is events are one inside another, events grow one inside another. Mm. And not side by side. So what we have been believing in the West, that in the computer, in the scientific development, everywhere it was said that uh, we can convert any event that are happening in the universe in a sequential manner, step by step, as a sequence of events. We disregard that completely. We say that this entire adventure could be one way of seeing things, but there could be another completely different way of doing it, which was developed in India. The Hindu monks developed and the Hindu scholars developed, and that was that the whole event actually grow one inside another, inside another, inside another. So that's why when one, in the Western science, if I don't have a defined state and there is something else inside, and then those things which are inside, we can go inside and then we find something more inside. So it's a kind of an architecture. So we said in chapter 2 that there will be architecture of confusion, and then to address that architecture of confusion, we go to the geometry, take 15 geometric shapes, and then in the corner of the geometric shapes we put other geometric shape. So we give a geometric representation of the confusion. In the chapter 3, we will give mathematical representation of the confusion. Why do we want to move every single information in the universe into confusion, architecture of confusion, and at the bottom of those confusions, where the journey ends in the facts. So the chapter 2 was a journey from architecture of confusion to architecture of geometry, and then chapter 3 is architecture of geometry to architecture of mathematics. So uh, so we call it phase prime metric. And then there are in the figure 3.1, you will find that you find a wheel, and then there are nested circles. So in throughout the book, I have used a very particular way of presenting the tables and charts, that is cyclic, always cycle, and then there are more cycles, more cycles, more cycles, and that's how I have explained different concepts. Why? Because if you go through from the beginning of the book to the end of the book, what you will find is that the new way, the way Hindus used to think in the classical Hindu schools used to think, building an architecture of confusion, then inside that some more confusion, some more confusion. If somebody really look into the topics in that way, how it feels different. So basically, when you go through the book and then you go through the tables and charts, you will start feeling how the futuristic way of analyzing events would look like. So I have already started the movement in this way. So that's why the figure 3.1, you will find this kind of chart, and then in previous chapter 2 also you find similar kind of chart. Let's go to number 1. And the number 1 here is uh, ordered factor. Ordered factor, what is ordered factor? Ordered factor is, suppose you have somebody has given you a large number of events, and you don't know what are these, and those are converted into geometric shapes, and then you don't know how to assemble those events, because what is predicting future or creating a scientific model? It means that what you have to do is to put the random or disordered things together, and then build an architecture um, so that you can create an infinite series. And the advantage of creating an infinite series is that what the set of patterns which are repeating, how can you repeat them continuously, perpetually, forever? Okay, so so what we have to do, whatever be the scientific protocol that is developed, what we have to do is we have to find a way to create an infinite series, infinite set of patterns. So what we did here is ordered factor, which was discovered 200 years back, and then that actually allows you to take, say somebody has given you 6 events. So 6 events you can arrange, you can take two of them, two groups, and then three events in each, or you can take 3 groups and 2 events in each. And so this kind of classification, if you continue 2 into 3, 3 into 2, 1 into 6, if you have 12 events given to you, then 2 into 6, so you can have 2 pockets, 6 events in each. You can have 6 pockets and 2 events in each. And then 2 into 6, 6 into 2, 3 into 4, 4 into 3, then 2 into 2 into 3, 3 into 2 into 2, 2 into 3 into 2. So in this way, 7 or 8 different ways you can arrange 12 events. You can calculate this mathematically for every single event. So we have went uh, doing calculations up to 400,000. Why not 300,000 or more than 400,000? It's actually, you don't need, because what are you going to do is you find a confusion, you go inside, you count up to three confusions inside, and you take another confusion, you go inside and you find 3 more. So when you make this kind of networking journey, uh, in this chapter you will discover that you don't need many numbers, you don't need many primes. Actually, you multiply primes to create integers, right? Like I want to create say 18, then I take primes 2, and 2 into 3, 9 into 2. So I take prime 2 times, and then prime 3 once, and then multiply them and then get an 18. So if we have primes, say we have 13 or 14 or 15 primes, then 86% of all the integers you can do. Why not more than 86? Basically, some part remains hidden. But we have seen that with few primes, we will take only 15 primes, and or 14 or 12 primes, whatever you feel comfortable when you are designing new hardwares. So basically, chapter 3 is end of the theory of artificial brain. From chapter 4 onwards, we will enter into hardcore physics, then hardcore material science, hardcore brain science, and hardcore beyond electronics, photonics, and magnetics, and all these kind of things. So up to 3 is concept exploration finished. So what we do here is arrange the number of events, and then how the plot would look like. Number 2 is 12 fractal topological series of 12 primes. So then what is that? Suppose suppose you take 1 event, 2 event, 3 event, 4 event, 5 event, 6 event, 7 events, and in the x-axis horizontally, and then vertically, how many ways you can arrange them. and then you rotate that paper, and then you get a 3D temple-like architecture. That is the core structure of the universe, according to us. But when you make machines, when you make artificial machines, you will not be able to put all the integers, because it's very difficult to design, because geometric constraints will be there. So suppose you are God and you want to create an universe, the cover page of the book, the temple-like architecture you get, that is a very, very ideal structure. That is the whole universe where all kind of possible symmetries are there. They are interacting and connecting. So in that temple-like architecture, the red balls are actually the inside the red balls. There are many kind of 11-dimensional geometric shapes or dynamics are there. So the temple-like architecture is 3D. Of course, 3D. It's simple. You don't have to think that something is beyond that. No, nothing is beyond that. But inside the red ball, some geometric shapes are there. But what happens when you make machines? When nature make machines, it cannot make completely because of the geometric constants. You make geometric forces and constraints and many other things are there, for which you are not able to place all the integers. You take some of them, but if you take product of 2, product of 3, and then create this temple-like architecture, they would look very, very different. So we have taken that if particular prime is dominating, so what are the 15 primes we are taking? 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47. Why we are taking 15 primes? Because when we were looking at the brain architecture of the human brain, we found that the prime number of components are there. When we are measuring the resonance frequencies of microtubule and different proteins, then we saw that the ratio of frequencies were in terms of primes, and then prime number of cavities were also there. So we found that 47 is the largest prime that you can find in the brain, in many of the many of the brain components. So we have confined up to 15 primes. So if you want, you can take 12 primes also, and you can go for 20 primes also if you want. There is no hardcore hard first relation. For an example, the temple architecture that we have created, nowhere it repeats, but you can find some similarity, self similarity as of there. And how long should I go to build this temple architecture? You can go infinity, up to infinity. It's your choice. But we have found that more than 200,000 or 300,000 oscillators is not necessary. And if you take 12 different primes or 8 different primes, you reach 10 to the power 11 number of components. And you will find that when you are looking at something, you find that your brain has 10 to the power 11 number of neurons and the glial cells. And then when you are looking at and concentrating on something, 10 to the 11 number of atoms are coherently vibrating. When you are looking at um, when you are looking at something, yeah, mm, your eyes actually concentrate 10 to the 11 number of atoms coherently into the system. And then also, if you want to build up the whole galaxy, you try to put them together and create a universe, then you will also find that 10 to the 11 or 12 number of stars are there. You have 10 to the 12 number of cells. So always nature converges. So if you take 10 to the 11 number, if you take a product of past 10 or 12 primes, you will reach 10 to the power 11, 10 to the power 12 numbers. So it means there is if 12 primes are there, you process 12 number of primes while engineering your reverse engineering your brain or very intelligent supreme system. It's enough, because nearly 86% or percent of your of the variations that will happen, geometric variations that will happen in nature, you can estimate. So basically, number 2 in this particular chart of figure 3.1 actually encompasses all these cases. So 47, if 2 dominates, how the temple-like architecture would look like. If prime 3 dominates, how the temple-like architecture would look like. If 5 dominates, how the temperature would architecture would look like. So in this way, you can make 12 or 15 or n number of city in number of temple architectures, but we have built just a 12 or 15. And number three is a beautiful relationship, e square plus phi square equal to pi square. This particular relationship you will find everywhere, and we discovered it incredibly. What we were doing is we were finding if I have uh, n number of choices, n number of random events are given to me, 1 2 3 4 5 6, and then number of choices we are putting vertically, and then we are rotating it and getting the temple like architecture. So if you look at vertically on the temple like architecture, so you go to the top of the temple like architecture that is on the cover page of the book, and then you look at vertically from the top, so it's like this, so you get a circle, so that we call polar plot. Now if you look at it, you will find something very very interesting, because mm, because you are coming back to this, you are completing a circle, right? So when you are completing a circle, suppose you have 12 events. So 1 2 3 4 5 6 7 8 9 10 11 12, 1 2 3 4 again. So the cycle starts. Suppose you have 400,000, 1 2 3 4 5 6 7 8 399,400,000, and then 1. So in this way, if you plot, you will find there are some gaps. And you cover it, all the options and choices cover it. You'll find some of the places there are holes, and if you connect them, you will find that the relationship of the diameter, distance, and and the ratios of perimeter to the diameter. This three kind of relationship, e square plus phi square equal to pi square, is valid over there. How is it happening? Why it is happening? We don't know. But one thing was very clear to us, that when we were measuring the electromagnetic resonance frequencies, electrical resonance frequencies, magnetic resonance frequencies, and mechanical resonance frequencies of proteins and then protein complexes, we found that the ratio of the frequencies of electrical resonances are E. E is 2.73, you know, logarithmic E. And then phi is golden ratio. So ratio of the magnetic resonance frequencies are phi, and then ratio of the mechanical resonance frequencies are pi. So it means pi is mechanical. So it is expression of life. Electrical energy we use in our body to do what? Electrical energy we use to um, to power different kind of engines, to machines, to signal. So basically, from food to hardware energy supply. So that part is done by electrical energy. In the conventional science, in conventional neuroscience, what do they do? They always consider that this electrical energy that is coming through food, actually that is giving us information. That is a huge difference from our approach in the entire book. We say that electrical energy actually limits itself within hardware energy supply, hardware management, and then everything. But it also generates a magnetic part of energy, which is for the information management. So, so electrical energy was doing everything. Now electrical energy has separate part, mechanical energy has separate part, and magnetic separate part. So that is classification for the first time in the history of mankind, in the biological sciences, or everywhere in the mathematical sciences also. We are isolating this kind of thing. So one of the beautiful thing of this number three, third type of base prime metric, is that E is an infinite series, pi is an infinite series, pi is an infinite series, but three of them come together, and then E square plus pi square equal to pi square, perfect two at the top. So just a simple quadratic relation are binding three infinite series. That's the most beautiful thing can happen. So actually I spent several months to confirm, is this really true, how it is true. So I take E 5 terms, 10 terms, 20 terms. I took even 40 terms and then square, and then I found the value, and then I checked. Perfect match. Perfect match. So it is a beautiful, sometimes you see simple relationship in mathematics, but that can change your life. Actually, this equation changed my life significantly. When I saw it in the vibrations of proteins, vibrations of neuron cells. And then when I saw it in a completely different phase prime metric, this number 3, and then I understood that everything is integrated, everything is are connected because because of the number of choices that you get, they have an internal relationship. Number 4 is um, uh, uh, is um, is how many ways you can arrange it. So it is number 4 is time crystal based phase prime matrices. So as I said, that figure 3.1 describes 10 different classes of phase prime metric. Only one has been described in this book very in detail, but because of the lack of space, we have not been able to address all other kind of phase prime matrices. But I believe that in my lifetime I also cannot finish exploring all of them. So what we would do is, in my lifetime, until I die, I will try to build it up in such a way so that they are simple, and then many other people have to come and contribute in each of the classes. So only one of them, or two of them, or three of them, partially I would investigate, because it's not one person's lifetime work. It needs hundreds of people to contribute to enrich this particular way. I am just showing the way. So number fourth class of phase prime matrices are all about, you take the order factor. Order factor means how many ways you can choose. So if you take 1 2 3 4 5 6 7 8 9 10 11 12 up to 48, then you will find how many ways you can arrange 48 events. 48. So 48 horizontal axis, 48 vertical axis. So if horizontal axis is 48, horizontal axis, vertical axis 48, so 48 by 48 is equal to 1. So tan 1 inverse 1 is equal to 45 degrees. So you get 45 degree. But if you go on increasing, slowly you will find this, that the maximum number of choices and the number of events given to you is 45. At 48 events you touch it, but very soon, by the time you reach 200,000 or 300,000 events, you reach up to 90 degrees. So that's why I say that more than that would not be required. So this transition of slopes, the way it is moving and changing and reforming the, so the temple-like architecture, it doesn't, it never looks like the way it is printed on the cover page of the book, because it will be like one something like that. So it's just like it's small arc of a sphere, so that the whole temple like architecture is a tiny point and flat lines on a sphere, on the hollow spherical surface. It's difficult for you to picturize, I understand, but this this is the truth. This is how it is. Number 5 is about mm, rotation. So what happens, sometime before I told that if you go to the top of the temple architecture and you see the number of choices, then what you can do is you go to 12 events. Okay, then 1 2 3 4 5 6 7 8 9 10 11 12. Instead of 13, it will be 1 2 3 4 5 6 again. So if you fix it up to 18, then 18, and instead of 19, it will be 1 2 3 4 again. If it is 400,000, then 400,001 will be 1, not 400,001. And then 2 3 4 5. And then if you look at it and connect the nearest neighbors, you will find some of them are moving in the clock direction, some of the points where you arrange the clock, and some of the numbers you find that they are rotating anti-clockwise. It's beautiful. For the first time, I realized how in the universe clockwise and anti-clockwise motion or the dynamics got created. So phase prime metric 5 is the most fundamental discovery that we have made. All these phase prime matrices are our discovery, but number 5 is actually gives you dynamics. So one thing you must wonder, why do we love mathematics? Because mathematics has no bias. It's the primes and then integers. They are not related to anything, no physical significance. We physicists attach significance to these mathematical numbers and relations. And then when I came to when we discovered actually this fifth class of H prime metric, where you see clockwise and anti-clockwise motion, That is the foundation of every single dynamics that is happening in the universe. So I often feel that these 10 class of H prime matrices are the beginning of looking into grand unification theory, or GUT. Very difficult to complete in my lifetime, but I think one day some scientist would come and then would concentrate on this particular thing. And then number six is convergent and divergent ripples. So if you take in a horizontal axis all the events 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then the vertical axis, how many ways you can arrange those events. And if you normalize that how many ways you can arrange, it increases. More the number of events are given, more the way it increases a number of way you can arrange them. But if you consider all the values as one, it's called normalization. That means for six or eight events, you can do it in a two-way, and that will also be one. 12 events you can arrange in eight-way. Instead of eight, you will write one, and instead of 48 events, you can do it in 48. So remove 48, it will be one. So always one, 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 and then you will find that there are ripples, beautiful oscillatory ripples that are connecting different choices. That is in phase prime. Why it is important? Because it suggests that even if you give equal importance to different choices in any engine, or any machine, conscious machine you are trying to build, then what will happen? There will be a periodic relationship and integration of periodic relationship between different kind of choices of events that are given. So whether you want it or you don't want, doesn't matter. If in nature some events are happening, say 10 events are connecting, happening together, and there are 15 events happening together, you will, even if you notice or not, doesn't matter, they will have some unknown relationship. You don't need to build relationship, but they will naturally have it because of the mathematics. So something like mystic or mysticism will be there. You will see it in the real physical scenario, but you mathematically those are already integrated inside the system. How it is integrated, that's not what we have investigated in this book, because we limited ourselves on how to create a self-operating mathematical universe that can govern everything around us, and we can use that to build the artificial brain. The number seven is distribution of phase, weighted distribution of phase. So annular 3D metric. So number seven. So what you do is when you look at the phase and how it is changing when in a polar plot. So you go to the top of the temple and look at it how it is changing. When this annular point and distribute the weight, that means suppose you have taken 400 events. Then if you go up to 400, which prime is dominating in the choices of arrangement? That means 100 events are, you try to arrange 100 events, 101 events, 102 events, 103 events, up to go to 140 or 200 events or 400 events. And then if you go up to 100, then you will find that prime 3 is dominating. If you go up to 200, you will find that prime 7 is dominating statistically. When you choose, go to the ordered factors. Ordered factor means how many ways you can arrange. So basically, how many events are there, depending on that, very particular prime will be selected, automatically selected, and its corresponding phase prime metric that is described in number 2, class 2 phase prime metric, will be automatically selected, and that will be governing the events. Isn't it beautiful? It is the most interesting of all. So basically, you are doing it randomly. Say you go somewhere and you find that, okay, 40 events, these are the 40 events I want to analyze. Okay, how its future will course. You follow the conventional science and you try to go, but if you do not go through the extensive detailed mathematics as we have outlined in the first prime metric scenario, what will happen is you some set of primes and its associated dynamics will be governing its evolutions and future. But somebody who has taken 48 events or even 23 events or 24 events, you will be seeing that the particular other prime and its related phase prime metric is governing the way the events are evolving. He never programmed it. It's mathematically programmed. So if you are biasless, no bias, just pure mathematics, then you will see this kind of things happen. And then number 8 is lattice points. So Gaussian primes. So you can different primes, they have their own relationship, just like paired primes, okay, sexy primes, gap of 6. So what do they do? When you create a phase prime metric, which you say that the governing control of the whole universe, and because you have all the possible choices, everything, you are not leaving anything, and number of ways you can integrate the events. So you cannot disregard this temple architecture. That is all the possibilities, by the way you can build it. So now what happens if the primes have a particular relationship between them? When the events will evolve, or the temple architecture, you will find some self similarity of patterns, and many such relationships are already invented and will be invented in the coming days. So when they do it, they will find that local patterns are actually building a relationship between a set of events that are happening over there, that are happening over there. Imagine if you are in the share market and you want to understand how the market evolves, then this kind of mathematics, or if you're in a complex scenario, extremely complex data you want to analyze, then this kind of things, this kind of mathematics is only resort to enter into it. That's why there is no theory for economics. Most of the economic theories are basically non-predictable. They predict upon the event that already happened, and then they go on saying randomly many things. Some of them, if matches, then they take the credit. But actually, a very scientific theory you have not been able to develop, or you have not been able to develop, because we needed this kind of phase prime matrices. So if we go to number 9, continued fraction geometric algebra. So fundamental constant. So when you increase, like e pi phi fundamental constants you get, but when you see the patterns are evolving, emerging, and plotting many different things, different phase prime matrices of class 1, class 2, class 3, class 4, class 5, class 6, class 7, class 8, you will find many fundamental constants are coming up, not just e pi phi, many of them. And then when you are looking at it, and you will find some fractal like features, you see the fundamental constants are coming up. So basically, you can find many fundamental constants. Why it is important? Because normally you think that fundamental constants that you see, gravitational constant or some other kind of constants, they are coming from the physical forces of the nature, and we are not able to understand. If if I live for a long period of time, I will show you step by step. There are some section in the book where we have outlined how primes are related to the fundamental constants. I mean, we have taken nearly 40 or 50 or other fundamental constants, but we can show much better way, because the book I had to keep within 400 pages, otherwise you will not read it. Uh, so I didn't get it, but I can show that many different kind of infinite series, geometric constraints are actually prime. Geometric constants are related to primes, and then the integers, the number system theory, is actually fundamentally behind those fundamental constants. Whether there is a physical relationship with that one, with the constants that we are getting, that we have to establish, because mathematics is independent of any system. So it is just purely geometric, or some other reason we don't know. The number 10 is a higher dimension. So what we do is, you can plot uh, ordered factor, okay, that how many ways you can arrange, but you can also find what are the different primes are required for each number of choices. Then you can make 1 to 10, all these classes of matrices, a completely new journey. So number 10 class of phase prime matrices are are actually different ways of seeing the choices of events. So you can create 10 more classes of phase prime matrices. So it's an infinite journey. Very, very big journey. So that ends actually figure 3.1. Figure 3.2, we actually plot an order using order factor metric. Only one types of order factor metric we are discussing in this book, uh, not all. And here in the horizontal axis in figure 3.1a, you can see that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 different choices. How do you do it? For example, for 12, there is a red color line in which you have 12 balls, and then what you see is that yellow balls are there, and those yellow balls are arranging with themselves in many different ways. So 6 into 2, that means 6 big yellow balls, and inside that six orange balls like this. So basically those are events, and you arrange them and then you rotate it, you uh, find that temple-like architecture in figure 3.2d. And then figure 3.2b, you find that for particular prime, how many primes are there in the universe, which are divided by 2. 50% of the primes, 50% of the integers. So it means all the primes we connect it with symmetry. So C2 symmetry, C3 symmetry, C5 symmetry, C7 symmetry, C11 symmetry, C13, C17, C19, C23. And then if you conclude its associated geometric shapes, then they converge 99.99999%. Just if you take only the primes and then primes contribution, it will saturate at 86%. So that's also fine. So 86% it goes alone, only the contribution of primes. And then because if you take how many percentage they are contributing. So for an example, 3 is supposed to be 33%, but if you calculate, some of them are also 2, because 100 by 3 is equal to 33.3. So 33.3% of the integers of the universe, whether you know it or not, should be divided by 3. But how many individual contribution by 3? That is 16%. So 5 should be 20%. 20% of the all the integers of the universe should be should be divided by 5. But actually some of them are divided by 3, some of them are divided by 2. So if you just calculate that deduction, then you will find that 5 contributes only 8%. So if you go on adding 50% plus 16% plus 8% plus you reach 86% approximately. So what happens is that, but they are associated with a particular symmetry. So what happens is it reduces on further, but you go on adding for each geometry, how much they are contributing to the formation of integers. Then you reach 99.99999%. That's why we have plotted in figure 3.2c contributions of all of them. Okay, and that is the horizontal. So when you take order factor plot and then you rotate it, this horizontal bottom is figure 3.2c. So that's why you rotate it. But normally it should be in homogeneous distribution of the circles in this temple architecture. Why it is homogeneous? Because when you make the universe, if you are the god and you're making the universe, you give equal contribution to all the primes, not the way they want to do. Then what you do is you understand your machine or engine that you make, or artificial brain, or the system that you make, they properly get the high resolution. For an example, 47 Broadman's regions are there on the cortex, and that helps us thinking and cognition and makes us conscious. These 47 regions all are equally spaced, and they all have importance. You can't delete one and then get full cognition or full consciousness that you want to have. So basically, all 47 choices are equally given probability. But if you cut me by half, these are the same C2 symmetry. Now we go to figure 3.3. In the figure 3.3, what we have done is for every integer number of choices, figure 3.3e, you go, and then you will find that what you do is you take the integers and you choose how many primes you need to constitute that one. That means how many independent dynamics you need, and it's a beautiful 3.3e choices. And then 3.3g is also my favorite. Here, for every prime we associate with the geometric shapes. So what happens, these geometric shapes you combine and you get the integers, right? And how do you do it? Like 30, we have given one example here. 2 into 3 into 5 is equal to 30. So you take two balls, you take a triangle, you put 2 and 2 and 2, and then put a pentagon, and then you generate 30. So how the 30 looks like. So in this way, the whole phase prime metric could be a beautiful adventure of geometric shapes. And then figure 3.4 is for each prime how the phase prime metric looks different. So basically horizontally, I have already described it. Horizontally you have number of choices, and then vertically how many ways you can arrange them. And then you take only the value of, for an example, corresponding to 6, you will take 6, 12, 18, and all these kind of numbers, and then you put the choices, and you connect the nearest neighbors. You will find it's a beautiful pattern. So in this way, for each prime you can get a different kind of patterns. Okay, so so if randomly you choose 140,000 events, and then some of the primes are dominating, that means particular phase prime metric will automatically, you don't need any engine. Please understand, when we describing chapter 3, one is very, very important. You do not need to program these kind of things. You take the random systems and allow it to go, but only keep the integer values, respect the integers, and respect the prime number of components who are vibrating and doing this. Naturally that system will follow this kind of complex mathematical relationship and integrate the vibrations and others naturally. Naturally don't need to program a single set of lines. Okay, so we come to figure 3.5b, 3.5, and here actually what I said, you take 12 events, so 1 2 3 4 5 6 7 8, number 12, then you see that some of them are moving clock direction, some of them are moving anti-clock direction. You just make the plot and you just connect the nearest neighbor. You don't have to connect. If you just look at the plot, for an example, there are 360-degree, and then we have tried to plot, say, 12 or 15, and then number of choices go radially outward, number of choices, and create a point. And when you connect the nearest neighbor, you find clockwise and anti-clockwise rotations, which is extremely beautiful. You can find 3.5b. We have given the picture. Some of them are going as if clockwise, some of them anti-clockwise. And then this is how the dynamics in the universe is encoded naturally. So this chapter 3 is the most beautiful thing that I have. And this particular type of matrices, phase prime metric is my favorite. Because you see motion, and as a physicist we love it. And then figure 3.6. Figure 3.6 I also explained to you that if you go only few numbers, you will find that the slope is 99.99%. So if you take a number of events and then you go vertically up, and then you connect 48. For 48 events are given to you, you can arrange them in 48 way, and then you take a slope, it's 45 degree. So 45, and then 90 degree. So what happens is when you reach, if you take that, take the product of those primes, figure 3.5c, you see that one universe is there, it's coming up, and then another universe. So what will happen is you take certain number of oscillators, you generate this kind of phase prime metric, and then you find that you have reached 10 to the power 11 or 10 to the power 12. Then after that, choices. Then after that, if you take 10 to the power 11 number of resonators, and then build some system, then after that increase in the number doesn't make any sense, because you already built all, or you have used all the symmetries that was there. So what you have to do is consider that as 1. Okay, so I take 10 to the power 11 number of atoms, I create something, and I consider at 1, and I take 10 to the power 11 of them and go on integrating them. That's how within and above structure got created. So this metric actually tells us. And then e square plus pi square equal to pi square is the way I say that from the gap, actually you can create this kind of things. It's number 6, prime number 6. And then figure 3.6, what we have done is we have just randomly plotted and then zoomed a particular part. And then we found that as soon as, so this is figure 3.7 actually. Figure 3.6 I described, and figure 3.7 here you will find that that ordered factor and number of choices that we have, all the number of events given to me and the number of choices. Then what happens mm, is we take a small part of it and then a zoom, and then the pattern looks similar, triplet of triplet. Then we go and then we see triplet of triplet. We go and triplet of triplet. Let me tell you one secret. I, all this mathematics that you are saying, I've not invented from my mind. What happened? We looked into the microtubule resonance frequencies and we found triplet of triplet grouping, and then all this kind of interplaying of the resonance frequencies and all these things. And I wanted to find how the hell, why universe is doing this. There must be some reason. It cannot be that uh, some protein based nano string is playing this kind of mathematics. So it cannot be so simple. So I went on, and this plot figure 3.7, and then what you see here, a fractal of triplet of triplet, triplet of triplet, triplet of triplet, go inside and inside and inside and inside. It's a never ending journey to infinity. That was actually the first discovery we made, and that's why we went for ordered factor and then all these kind of things. Actually, our journey to phase prime metric actually started from figure 3.7, and that's actually derivative of microtubule vibration. So in the book, this story is not written how it was discovered. I have arranged the whole book so that you have classified 10 chapters, 10 different kind of knowledge that you need to know to build an artificial brain, but it is not written in a way that how it was discovered, how it was invented. But I'm telling it in the tutorial. So now if we go to figure 3.8, figure 3.8 is another very interesting class where you find that figure 3.8b, look at it. It's a very popular plot that you will find many places. Density of primes distribution with integers, and if you normalize it, how does it look like? So from here also you can understand that you do not need to know large number of primes. Nonlinear variation of prime density that actually give rise to different kind of dynamics. You have already understood. So all the events that are happening in the universe, we are converting them into geometric shapes. Since we convert them into geometric shapes, geometric constants come into play, and the bias towards a very particular choices go away. And but at the same time, the density of primes, if they change non-linearly over the integer space, what is that? What is this jargon? Is that if you go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, at some places of this integer space, if you go through, you find many number of primes, and then you will find a lot of integers you pass, but there is no prime, and suddenly you start seeing the prime. So this is nonlinear density distribution. This nonlinear density distribution you find most within 10 to the power 12. So if you look at this this figure 3.8b, then you will find that after 10 to the 12 there is not, it is not that interesting. So basically 10 to the 12 number of oscillators. After that, even the nonlinear features or unpredictable features are very unique relationship, building up a unique relationship between different totally uncorrelated events are very high. So geometrically self-similar. Suppose you are doing in share market, a very particular geometry comes, and you are analyzing socioeconomic behavioral change due to coronavirus, and you are finding, you convert all the information into geometric shapes, and a very particular geometric shapes you find where particular set of primes are dominating, and their neighbors, density of primes in their neighbor is like this and like that, and then that geometric shape will change in a particular way due to COVID virus, and then you will find that relationship is very similar in the share market, where the similar kind of geometric shapes were there, where similar kind of primes were their neighbors, and then they are also regulating and generating the unpredictable features. So some scientists can correlate and plot a equation, but those whole exercise would be a nonsense exercise. So so we now come to figure 3.8 FGHI. All these are similar. What we've done is, which prime is dominating in the integer space. So different primes are dominating, and then you will find that some prime dominates, goes down, and then other prime comes up and dominates, and then that prime may again come up, and then other primes come up. Some primes are silent, they don't come up. So if you go through all the integers means all the events given to you, and then you try to arrange them, you will find that those primes are not dominating. It's very unfortunate, but there are some silent primes which whose dynamics you don't see. And number nine. Number nine is actually figure 3.9 is a ripple. As I said, that you have many choices, events given to you, and you need to arrange them, but you make it one. Then what happens when you forcefully make all the maximum number of ways you can arrange the events as one? Then what happens is you see ripples. That means unwanted periodic connection between different integers, set of integers of events. It's beautiful, and then that is actually there. And also you will find that we have a triangular plot here in 3.9f, where we have normalized integers, normalized phase, and normalized ordered factor. If we plot, we find a straight line. So uh, that means when integers are increasing, the way it will be impacting the other events remain constant throughout the integer space. I tell it again, the way it will unpredictably affect, that also has a universal rule, and that is explained in 3.9f. So it's very important that you look at and try to feel that how that will control the events that are happening around us. Now we come to figure 3.10. In figure 3.10, we took the paired primes, okay, prime gap between the integers. So gap could be 2, gap could be 3, gap could be 4, and then you can create a completely new kind of phase prime metric. So phase prime metric is not that always you have to have ordered factor. You can take different kind of primes, and you can plot them and then plot their gaps. You can take Rho primes, you can take Gaussian primes, you can take Einstein's primes, Eisenstein prime, and then if you try to plot them, and then you can generate completely different kind of primes, and you can make an adventure. And then the last is in the description is figure 3.11, and it's the 10th prime, where what you do is Dodecanian algebra comes in. So what happens is when you put clocking effect, clocking effect means figure 3.11b. If you go, then you will find that if you do mod 30, then there are some relationship, cross relationship, and self similarity of different primes. And then when you create a tensor with different choices to explain what is happening, tensor or grid I explained while explaining the chapter 2, that information is converted into geometric shapes. Then what happens is this kind of event is correlated to that kind of event. That kind of event will go to that, and periodically they will repeat. So you will find many different kind of unexplainable periodicity in the events happening in the universe, and you can estimate that with this kind of modulo. And then a very interesting thing, which we have not discussed much in details, that every single prime 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, and 47, if you search in the cultures, they have a very particular physical significance. So we have gone through the history of mankind in different places, and then we have converged them into it. So basically, when C2 symmetry is applying, then you see always other side of the truth. So when you try to solve problem in following our way, then when you go anywhere, you search for confusion. But when you find a confusion, for an example, a very good team, Brazil, will win the World Cup this year or not, because Brazil is performing the best. But it never happens that Brazil wins, right? So it's a confusion that the best team who are playing the best in just before the football cup, and then they lose out in the first round. Anyway, so suppose you get a confusion that Brazil will be winning the World Cup or not, and then you try to find out that other side of the truth. So that means in the confusion, first you should split. You enter inside a confusion. You try to find C2 symmetry, other side of the truth. Some confusions which are completely different side. That means um, they are outplayed by certain rules. Say rain comes in and something, and then they're not able to perform, and then they are outperformed by some incredible good luck by other group. They try to put in the goal, it is not going and something. So totally, completely different side of ability actually pours in. Then space, time, state. You try to see which time in the they are playing, and then past, present, future. You try to see space. You try to see in this way. So and figure 3 point figure 3.12a, that is kind of is very important, because each metric, when you apply, you see some you metric apply, you get infinite series. That infinite size is projected, and from infinity it is reflected back. So what is that? You will slowly learn. Actually, what happens is you create geometric series of infinity. Geometric shapes repeat, but certain geometric shapes are repeating after that. So when you go to infinity, those particular features actually come back, and then you have multiple infinite series, multiple phase prime matrices are operating. When it goes to infinity, they interact, and then the common geometric shapes actually come back, or uncommon geometric shapes become the host, and then bring the common shapes become the host, and the uncommon shapes become the guest, and you get a completely different kind of fusion geometric shapes to be returned. And those kind of equations, how would that be, is feedback from infinity. So for 10 different classes of matrices, we have selected some identities that you will observe. They are very important, but unfortunately in the book we could not discuss much about it. So how to use a phase prime metric? That is figure 3.13. Okay, so so when you try to apply phase prime metric, how do you go towards it? So there are 10 steps we have written that try to find out geometric shapes, and then find out the integer, and then you go to the phase prime metric. What you do is you apply C2 C2 and C3 symmetry into the event. For an example, you took some event and you created 3 geometric shapes. Now what you do, you find that there are C2 symmetry. If I want to apply, this triangle has to be put in the structure here. Then you don't see what happened for the event. You just think about mathematics. And then 2 into 3, that means you first apply C2 symmetry, that other side of the truth, and then time, past, present, future. And then what you can do is you see some confusion, and then you find past, present, future, how the confusion will look like. Then you see other side of the truth in the past, other side of the truth in the present, and other side of the truth in the past. So this is 2 into 3 and 3 into 2. So you put them together, you get the phase prime metric. That's the beauty of it. So this is how do you apply. So now you lock in with PPM, and that is a step 2, and a differential symmetry. So that means if something is missing, you just fill it with it. Arithmetic of integers. So what you do, you just find the self-similarity of that and create the infinite series. And step 5, common part fuse. So there are common geometric situations. So you take the whole infinite series out from the same phase prime metric, whole set of triangle. Okay, this set of geometric architectures go, and then I get an infinite series. So common parts fuse, and then you create it. Then constellations. So 12 geometrics, 12 different kind of fractals. So if these primes are dominating, that primes are dominating, then those features you apply to them, those independent infinite series of events that will be happening. And then normalization. So you find the correlation. So periodicity, where is there? So if the periodicity is not there, you add the geometric shapes ad hoc manner there, and then create a perfect periodicity in all the things. And then transformation. So density of primes. So density of primes is different to different places, and it's different. So those primes are dominating here. If those primes are dominating, then other primes related geometric shapes would come there. So ad hoc manner, you put those geometric shapes. And now you were not thinking about how the events look like. No. And those physical significance have gone. And then you are just looking at the geometric shapes and doing it. And then step 9 is morphogenesis. If this kind of geometric shapes they come, and then we know that to regenerate symmetry, then similar things will come here, similar thing will come. So that kind of morphogenesis. And topological criticality. That means this geometric shape, if I try to put there, it will not be fitting. So I cannot generate symmetry. So I have to remove some set of information, and then I have to put it somewhere else to 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 manage the topological criticality, because time, all the geometric shapes are bonded inside a temporal circuit. So you cannot put a very large temporal geometric shape inside one small temporal geometric shape. So these are the 10 things, steps you should follow. And then we come to figure 3.14. There is one example. We have tried to solve a big data problem. And how do we do it? We look at in the left column, you see that there is a big data of diabetes. And then apparently, if you look at it, you see a triangle. And then you look at the ratios, and then you create the time crystal. And then if you look at it more deeply, in the second row, you will find that you go a little deeper, and then you find the geometric shapes inside the geometric shape. And then you go on build the time crystal. And then in the layer 3, what you do is inside those geometric shapes, you find some more geometric shapes. And then you find time crystal for that. And then in the layer 4, again inside those geometric shapes, you find more geometric shapes. So the most dynamic points or most silent points in a very, very dynamic situation, you look into it and then build a time crystal like that. And then you put it in the phase prime metric, expand the way I have explained just now, and then you get new kind of dynamics from the diabetes data. You find that some incredible things are happening over there. So using phase prime metric PPM in the artificial brain. By now you have understood that how this is going to happen in figure 3.15, and I have explained in this chart actually how this association, expansion, and fusion, these three kind of steps, how it would help taking a geometric shape, converting it, and then creating infinite series of geometric shapes. Remember, infinite series, when I'm talking about, it's not integers, it's the geometric shapes that are. So in the first step, triangle; in the second step, triangle with some lines; in third step, triangles with lines, with square, and then this goes on. So from the phase prime metric, we find out. So association, expansion, and fusion to convert them into a simple geometric sheet architecture. So these are the three fundamental steps to go ahead. And then figure 3.16, we take three kind of phase prime matrices. One is order factor, means we take the events of choices given to us, and then we vertically we find how many ways we can arrange it. And then prime composition, that means and how many primes are required to make a particular integer. That means 2 into 3 into 5, 30. So we need 2, 3, 5. We need 3. So value of 30 would be 3. So you can make a phase prime metric like that. And then prime gap metric. Prime gap metric, so what is the difference between the primes? And then you can take that for number of choices of events, and then you vertically you put the gap, and then you find another pattern. So first you should apply order factor metric to transform it, then prime composition matrix to link it, bridge it, and then the incredible dynamics you will add in the step 3. So figure 3.16 tells you what are the different classes of phase prime matrices that you should be using to transform the information that you are getting from the external environment. And finally, figure 3.17, we have put a single chart to explain what are the advantages of phase prime metric. Just imagine in future there is no software engineer write the code, no humans required to think. You just can make a conscious machine which will be operating by itself, because we think that we are made of phase prime metric, and another human is made of phase prime metric. I don't need any teacher to interact with other person. I can continuously tell new things, and he can continuously tell new things, and we can interact, because whatever it is, I cannot cross the pattern of primes. All the possibilities are encoded. So people try to find out what is the next prime, next prime, next prime. Our concern is not that. We take the primes as absolute, just like God. And then that primes, when they compose the universe, all the possibilities, how the temple architecture is built. I am a temple architecture, another person is a temple architecture. We interact, but before he tells whatever it is, my phase prime metric knows that he cannot create a new pattern other than me. That's the end of it. Thank you very much for listening to me for such a long time, and I hope that I have been able to explain the thing to you very well. Whatever it is, if you have any questions, just put me. I will come back with the chapter 4 next time.